Welcome to today's webinar, Best Practices for Running SAP HANA Workloads with EC2. Our presenter today is Steve Jones. Steve is an information technology leader with 15 years of experience, including 11 years of SAP basis and related technologies, as well as 6 years supporting multi-million-dollar ERP system implementation projects. We also have Bill, Tim, Naresh, and Sabari serving as our webinar moderators. They will be engaging with you and answering your questions throughout the presentation while Steve presents. Steve, welcome. The floor is now yours.
Awesome, thank you. We're absolutely delighted to be speaking with you today. We've got a lot of exciting things to share with you, especially with our recent announcement around our X1 instances, which are optimized and designed for SAP HANA workloads. I'd like to jump right in here and talk to you a little bit about why enterprises are actually moving to the AWS platform. Now, a lot of customers that we hear from actually talk to issues they're having with fixed costs or investments that are very capital intensive, and over time they really see a lot of the money that they have are tied up into high maintenance and different run costs, and not to mention being in this cycle of procuring hardware really leads to sometimes having really outdated technologies or hardware in their own data centers. And contrast that with the future, which is our platform, which is where you can actually pay by the drink. So very, very much on-demand fashion. You can actually be responsive and agile to your business. Again, provisioning compute and other resources when you need them. And learn to fail fast. So businesses are actually learning to take on new initiatives and be super innovative. And this continual iteration and innovation is really leading to improved agility and customers of ours coming up with new technologies, right, and new offerings for their own customers. And unless you're really in the hosting business, it's unlikely that maintaining physical infrastructure really is a core reason for business. And it's really what you do with the infrastructure that sets you as companies apart. And our cloud is really what allows you to get rid of this undifferentiated heavy lifting that comes along with data center management. And first, it really breaks the cycle of large, risky capital purchases that often tend to make people risk-averse and trades it for greater flexibility using operating income. It also eliminates the need and the risk of cost of capacity planning by allowing for businesses to acquire exactly the capacity needed at any given time. And I'll talk a little bit about how X1 instances actually help us do this. And third, it simplifies the complex management tasks inherent in keeping a data center filled with heterogeneous technology running smoothly. And as I just alluded, oftentimes technology can become outdated very quickly, and the AWS platform really allows you to stay up to date with technology as trends evolve very rapidly. And ultimately, the headaches involved in establishing and running data centers just become eliminated. And really, it's a result of these benefits. Much less time and effort needs to be spent on infrastructure, and this reduced investment there allows for more time to focus on new business initiatives to deliver more value for your customers and really lead to competitive differentiation. And as a result, you're then able to put more resources on innovation in order to stay ahead of new and exciting sources of competition. So really the investments that we've been making as it relates to AWS platform around SAP are really to enable driving business benefits for you as well. And SAP themselves have been a customer of ours since 2008. We're a global technology partner since early 2011, and we've been working with them for quite some time now on the certification of our platform, and then working with customers like you to ensure that the platform is robust, it's reliable, and it's performant in order to run your most mission-critical SAP systems. And we've worked really closely with SAP to certify, again, all their solutions for production deployment on AWS. And if you take a look at this, this is an indication of the timeline since, we really started working with SAP as a customer back in 2008, the certification process shortly after becoming a technology partner in 2011, and today. And what you see here is a couple different things. Early on, we learned together with SAP what it meant to really be hosting SAP solutions on the cloud. And we started with maybe some of your less mission-critical application like business objects and developer editions, but quickly grew from both our relationship with SAP, but more importantly, the feedback that we were getting from customers as we implemented and integrated these changes our customers were asking for into our platform. we started actually making improvements that, again, also increased the customer adoption. And so what you also see is the trajectory, and I would say definitely the last 18 months, the trajectory of customer adoption on AWS has been tremendous, and we'll talk about that here in just a moment. Culminating with the release of a new instance type called X1, which I'll go into great detail here in just a moment, but really designed in a large part for SAP workloads. It's very stringent requirements. Now, let's talk a little bit about which solutions are certified for use on the AWS platform today. And this it includes a broad range of SAP applications, including the latest solutions like S4 HANA, Business Suite on HANA, all the SAP solutions that are based on NetWeaver. In fact, you can run any SAP solution based on NetWeaver 7.0, which is quite old, or higher, up to the latest release, including 7.5. This also includes any SAP solutions backed by the databases you see listed here, including the flagship SAP product called HANA, or their MaxDB instance, Sybase, ASC, DB2, SQL Server, and a whole litany of other solutions that SAP brings to market around the mobility platform, including Mobile Secure and their Unwired platform, etc. But really, what are customers doing to now? And this is really key. These are actual deployments that are going on now, and I'll get into a couple specific use cases here in just a moment. But today we have customers who are deploying S4 HANA, Business Suite on HANA, Business Warehouse. A lot of customers actually doing Hybris implementations for their e-commerce, CRM, and then your classic Business Suite scenarios. For the customers who just haven't decided whether HANA is right for them or not, we see a lot of customers still wanting to take advantage of the benefits that I talked about just a bit ago around cloud, and actually migrating their Business Suite and other SAP solutions onto the AWS platform. One of the early customers we worked with around the deployment of SAP HANA on AWS was Kellogg's. Now, Kellogg's, as you see here, they needed a better way to really track and model the promotional costs for their particular products, and they called this trade spend. And SAP had come out with a new product called Trade Promotion Management. It was a combination of SAP CRM plus SAP BW on HANA. Kellogg had made an investment already in the CRM solution on-premise, but they didn't want to purchase additional infrastructure. And so they looked to AWS to see if they could actually deploy SAP HANA on the AWS platform instead of investing in costly appliances. And we worked very closely with them. And by their models, they're actually able to save almost nearly $1 million over 5 years versus, again, the traditional on-premise infrastructure alternatives. And today, they've actually, as you saw in the video leading up to this session today, recently gone live with their APAC division, their SAP systems on AWS, and we're happy that they're a happy customer of ours. Another customer that we work really closely with, and is a great example, is Brooks Brothers. Now, Brooks Brothers, again, this is interesting because they actually looked at SAP HANA and the solutions that they were implementing for their business. Again, not wanting to make costly investments in infrastructure, they decided to actually leverage the power of AWS and our platform with a cloud-first strategy that included going first with SAP. And since actually deploying Brooks, the SAP CAR and the SAP CRM in production, powered by SAP HANA, they're actually working on additional implementations of SAP, including HANA on the new X1 instance, which we'll talk about here in just a moment. Again, providing the agility and the flexibility that they needed in order to really bring the new SAP innovations that were coming to their business. Now, customers, including those I just mentioned, for a while have been asking us for instances with lots more memory than the ones that we previously had. And really, after a couple of years of working closely with SAP, we released back in May the X1 instance. And this is not a typical hardware appliance that you would roll into your data center. This is a native cloud platform. It's not hosted in a colo environment, or it's not another hosted solution. It's an AWS instance type that you can consume just like you would any other instance type, spin up and down as you need, and with all the flexible pricing options. And we'll go into those in just a moment here. As I mentioned, it's a new addition to our memory-optimized family. It's designed for running large-scale databases like SAP HANA in the AWS cloud. It offers up to 2 terabytes of DDR4-based memory, and each instance is powered by 4 Intel E7 processors. And these feature high memory bandwidth and larger L3 caches to boost the performance of in-memory applications like SAP HANA. And in addition, these instances are the first instance to leverage the Elastic Network Adapter, or we call it ENA. This is a new version of enhanced networking, which is a custom network interface combined with a driver that is optimized to deliver high throughput and packet per second performance. And using ENA on X1, you can actually utilize up to 20 gigabits per second of network bandwidth, in addition to another 10 gigabits of dedicated bandwidth to Amazon EBS, as the X1 instances are optimized by default at no additional cost. Now, these instances are also enabled to increase cryptographic performance using the latest AES&I features supported by Intel. We also are exposing and supporting the transactional synchronization extensions, or TSX, to boost performance of these in-memory transactions. And we also are exposing and supporting advanced vector extensions. And these process instructions expand most of the integer commands to 256 bits. And this is something that, again, comes native to the platform and that we're exposing through the hypervisor layer. Now, at the hardware level, we've also enabled single device data correction, or SDDC+1. This will detect and correct multi-bit errors to identify and disable failed DRAM devices. So again, high resiliency within the platform. Also not listed on the slide here, but you can also configure C states and P states like many of our other instances. For example, you can use C states to enable higher turbo frequencies. You can also use P states to lower the performance variability by pinning all cores at, say, P1 or higher P states, or consistently running at the base CPU clock speed. So a lot of control that you have with this instance. Now, X1 instances are also certified by SAP for deployments. Of all the solutions you see listed here, this includes the next generation Business Suite S/4HANA, Business Suite on HANA, Business Warehouse. We've done a lot of benchmarking with this, and this came in at 131,000 SAPs. I'll talk a little bit about more of that here in a moment. You should also note that X1 instances are also certified for other SAP applications that run on NetWeaver, but maybe not on HANA. So for other RDBMS solutions, like I listed earlier, DB2, SQL Server, Oracle, you can run those on X1 and ensure a proper performance. Now let's take a look just a little bit further into what dive in here and see what you actually get on the instance here. And just nearly 1,952 gigabytes of RAM or 2 terabytes of RAM. And we're allowing the latest use of the HANA support packs, and those are also supported. Now, as you may know, SAP HANA stores and processes all or most of its data. And so we need to protect ourselves against data loss by saving the data in persistent storage locations. And to achieve optimal performance, the storage solutions used for HANA, the data in the log areas in particular, have to meet specific performance criteria. And we worked very closely with SAP to certify both our general purpose SSD or GP2 volumes and our provisioned IOPS or SSD IO1 storage solutions for SAP HANA workloads with the configurations that I've shown here. Now, the general purpose volumes really balance price performance for a wide variety of workloads, while the provisioned IOPS volumes provide the highest performance very consistently for mission-critical applications. I would also note that the heavy I/O operations like startup can actually complete a little bit quicker with the total throughput that you see available with the provisioned IOPS configurations. But both are certified for production. Both can be used and meet the performance criteria from SAP. So really what you have is a couple of options to choose the right storage solution that really meets the needs, that balance the needs from a price and performance cost perspective. I've also listed the non-database areas and the standard configurations we recommend. These are consistent across whether you use the HANA data and log area. And you'll notice here that we're also using the new throughput optimized volumes type for the backup area. This volume type provides low-cost magnetic storage designed for large sequential workloads. And SAP HANA uses sequential I/O with very large blocks to back up the database. So these volumes provide a very low-cost, high-performance option for the scenario. Now this volume size, the backup volume is designed to provide optimal baseline and burst throughput, as well as the ability to hold several backups. You're absolutely at liberty to resize this volume or add additional storage if you need to after the initial setup. Diving into the storage architecture for HANA just a little bit more, again, I talked through the various solutions that are available. Both of the GP2 and the IO1 storage solutions that are certified, these are backed by solid-state drives, so you get single-digit millisecond latency. And the other thing to make note of is that we are stratifying multiple servers in the availability zone, so you don't have to worry about doing any additional striping or mirroring at the operating system level. The other thing that's interesting to note and important to realize on our platform is every HANA node, especially in a scale-out configuration, carries its own data area and log area. So we have this concept, which is shared nothing concept, such that if you have a failure of one node in the accompanying storage, it doesn't take out the entire cluster. And so I'll show you here in just a moment how simple it is to actually recover from a failure. It's very resilient and low cost actually from an HA perspective. Now X1 is available today in 7 of the 13 regions that we have. We've got this concept of regions and availability zones, and so we've got X1 available in 7 regions and multiple availability zones within each region. So we've made a tremendous investment in allowing customers to actually run very large SAP workloads in a very distributed fashion across the globe. Now compared to other EC2 instances, these X1 instances really have the lowest price per gigabyte of RAM, and definitely are ideal for running in-memory databases like SAP HANA. And that said, though, we have many different types of instances and families of instances to support a variety of workloads. Each instance family is purpose-built and optimized really for a specific workload, and you see some that I have listed here. Now, for those that are familiar with SAP sizing, you'll recognize the SAPS metric here, and SAPS really is a hardware-independent unit of measurement that describes the performance of a system as tested with what SAP calls the SD benchmark, and we've done a lot of benchmarking on the AWS platform. And what this allows you to do here is really take the output from the standard SAP sizing tools like QuickSizer, and then map the requirements to the proper instance type on the AWS platform. And what we see is a lot of customers use, in addition to the X1 and the R3 instance for SAP HANA, they'll use the R3 family for the database instance type in a class. And then for the application tier or the stack, they'll typically use the compute optimized family, which brings a little bit more compute and is optimized from a price performance perspective that way. When it comes to non-production instances, customers, we use a variety, but we often see customers using the general purpose instance types for non-production. But the key here is that any of these instance types can be used. They're certified by SAP. You can use them in what SAP calls a 2-tier or a 3-tier configuration. So scaling to very large environments on AWS, supporting hundreds of thousands of SAPs is definitely possible, and we see customers doing that today. So let's talk a little bit about getting started with HANA on AWS. First, we should take a look at sizing. Now, SAP offers SAP certified systems that are configured to meet the specific SAP HANA performance requirements. And we have those on our platform that I've just talked about. Really, the first thing we encourage customers to do is for new implementations, just to go through the SAP QuickSizer. And it's okay. In a previous life, I was often concerned that actually going through the QuickSizer, I might not have all the business processes mapped out, or the business may not have a really good idea of all the business processes that they were actually going to be implementing. And therefore, I wasn't quite sure all the time whether I had a good handle on how much hardware I needed to be procuring, and I would often pad it by an amount. But on the AWS platform, you can actually afford to get it just a bit wrong, and I'll show you why in just a moment. But we encourage customers to kind of get a good rule of thumb, definitely from the SAP QuickSizer, and do that initial SAPS mapping from the QuickSizer to the AWS instance type. If you're going to migrate an existing business warehouse or business suite system, SAP does have two different sizing reports that allow you to really get a good feel for what's going on within the system that you have, and more importantly, how big of a system you need to provision for HANA. Now, the nice thing on AWS is that you don't have to go through this problem of having to oversize, right? So really think of sizing at AWS as an opportunity to right size your SAP environment for actually what the business needs. And then over time, as you need to add additional capacity, whether it's scale up or scale out, this is something you can do very, very easily. One of the other things we really look to do is to take a lot of the muck and the difficulty out of SAP deployments and really provide seamless approaches for customers to really get started. And one of those is the SAP HANA Quick Start reference deployment. And with this reference deployment, we basically are provisioning we give you the tool to actually provision a virtual appliance such that it has the ability to provision all of the AWS building blocks, including the instances, the X1 or any other instances supported for SAP HANA on our platform. These quick starts, they're modular, they're customizable. I'm actually going to walk through it here in just a moment so that you can actually layer on additional functionality on top of it or modify it for your own implementation. Key here is that we're following AWS and SAP best practices. So when you actually get this virtual appliance, you know that the configurations of both the AWS infrastructure as well as down to the SAP the HANA configurations and the operating system configurations, they're all done in a manner that is again, follows our best practices and SAP's best practices, such that you're getting performance out of the system as it's designed. And the best part is you can actually provision and deploy SAP HANA in minutes, seriously minutes versus weeks or months, as you would traditionally find in on-premises installations. If that's too much, we actually have a large partner network with many SAP partners who are very willing and happy to provide different types of services, whether it's implementation or helping through a POC or evaluation, or whether it's managed services, right? So maybe doing application managed services or anything else you might need help with. And we're happy to help you, connect you with a partner if you have these needs. Now we've done a lot of work ensuring that our partners are equipped to help you. We do a lot of training with them to help them understand the subtle nuances between running SAP solutions on AWS as opposed to on-premises or in a hosting environment. So one of the things I wanted to cover today is some tools and techniques for actually migrating SAP HANA or other databases to X1 on AWS. And so today I'm actually going to cover 4 migration scenarios as summarized in the table above. The tools and methodologies are listed here for each of the scenarios. I'm going to be discussing those in great detail in just a few minutes here. But the 2 common migration scenarios are, if you're already deployed on AWS, whether it's another database or HANA, there's a couple scenarios we'll walk through here. Or if you're actually migrating from another database or SAP HANA system from a location that is not EC2 today. So again, with the release of the AWS X1 instance type, this really increases the options available for scale-up HANA deployments and scale-out deployments. Now when you scale up, you're utilizing the capacity of a single SAP HANA node by switching it to an EC2 instance type that provides a larger capacity. For example, if you're using today an R3 instance type and it becomes too small for your workload, you need more memory for HANA, then you can quickly change it to an X1 instance type. Now the limitation is the maximum capacity of a single EC2 instance. In AWS, really scale-up enables you to start with the smallest EC2 instance type that meets your needs and then grow as your business requires it. If your requirements change or new requirements surface, you can scale up really easily and really keep pace with those changes. Now when we scale out in scenarios 2 and 3 here, you add SAP HANA capacity by adding nodes or new instances to the SAP HANA cluster, and this can be done using the Quick Start. For example, once you've reached the maximum capacity of, say, a single EC2 instance, R3 or X1, you may decide to scale out your HANA cluster and add more instances. The more likely scenario is that your sizing, upfront has revealed the need to plan for scale-out configuration from the start, and we give you the option of actually deploying multiple HANA nodes in a scale-out configuration with the HANA Quick Start. Let's talk really briefly about what a simple scale-up solution from R3 to X1 would look like. So here we have just a simple SAP HANA database running on an R3 instance of your choice. Really, it's simple actually as shutting down the virtual machine. Note the virtual machine is unavailable, so we need to plan for downtime here. All we have to do is actually change the instance type in the AWS console or issue an API call to change the instance type for this virtual machine. And then we start the instance back up. And we're automatically placed on the new physical host. So what this means is that in a matter of minutes, you can actually be running on a new hardware platform, whether that's to take advantage of a newer CPU technology or on a new hardware platform like X1 to take advantage of more memory. Now this is best for scaling within an instance family, so say you're starting with an R3 instance and scaling within that family. I'll go through the recommended approach when you're actually going from a very large jump, say from R3 8 extra large to X1 32 extra large, which has 2 terabytes of RAM. But this is possible. Say you run into a situation where you need a little bit more headroom and you need to make a change very quickly. The recommended scenario here is to actually perform a data migration from R3 to X1. Again, this can be done during a single maintenance window. The benefit of this is it actually allows for you to take advantage of, again, what I talked about earlier, which was the new ENA support, which does require a specific OS kernel version. The storage configurations for X1 that I talked about earlier are just a bit different than what you would be using on an R3 platform. So again, in order to take most advantage of the performance capabilities we give you the X1 system, we do recommend that you actually walk through this process. So the first thing we do is we take a simple backup to EBS. The second is to provision a new SAP HANA instance using the quick start, which I just talked about before here. We attach that backup volume from the original source system, the R3 instance. We attach it to the X1 instance, and then we restore from backup. You're going to have some additional cutover steps. You might need to replicate some of the HANA configurations before you actually turn the system live. If it's a BW system and you're actually making use of a larger instance, you may need to repartition the data. And since we're actually talking about SAP applications here, there's a good chance you're going to need to actually repoint the application tier before we can resume operation. But again, it's something that, especially with the quick start, can be done in an iterative fashion so that you can actually plan for upfront and then execute the cutover during a single maintenance operation. When we talk about migrating existing scale-out clusters to multiple X1 instances, it's a very similar process. But first, we really calculate the total memory required so we understand how many scale-out nodes we need on the target side. For example, if your current scale-out environment configuration is 10 R3 instances, it's roughly equivalent to like 2.5 terabytes. In that scenario, you would need to choose a scale-out configuration with at least 2 X132XL nodes. Now, depending on your SAP workload, again, 3 or more nodes may be best. Now, just like before, we're backing up our source system, we're detaching our backup EBS volume, and we're provisioning the new environment, the new cluster with the quick start reference deployment. We attach our backup EBS volume to the X1 instance and then recover our database and follow, again, the same cutover steps which I just outlined. Key here, and I've listed the node, is understanding how to migrate from a multi-node to a single node. There's actually a method for that. And why would I want to do that? Well, again, as I mentioned earlier, the X1 instance has the best pricing from $1 per gigabyte. So if you're currently running on a scale-out cluster of R3 instances, it may make sense for you actually to scale to migrate into a single X1 instance and take advantage of not only the new performance aspect of X1, but also the added cost benefit there as well. So let's talk a little bit about migrating to SAP HANA and AWS from a different platform. And for example, this could be, again, on-premises infrastructure or another cloud platform outside of AWS or another hosting provider. But this really involves 2 major migration scenarios. First, we could be migrating from AnyDB, which again could be DB2, SQL Server, Oracle, or otherwise, or we could be migrating from another SAP HANA database or appliance from on-premises. Now, migrating from Another database outside of HANA typically involves operating system and database platform changes that we need to take into consideration. Migration also might involve additional technical challenges and impacts. For example, you could have ABAP code changes. It could be custom code that you need to take into consideration that has operating or system level dependencies, such as database hints. Some other things I wanted to call out, just to give you some learnings from what we've learned with customers. Some other operating system specific dependencies could be custom file shares and scripts that might need to be recreated or moved to a new solution. Again, especially if you're changing database solutions. Specific kernel tunings or operating system tunings, kernel parameters that need to be accounted for. Now note that our quick start actually takes into consideration the proper kernel tuning for both the X1 system itself plus for SAP HANA as recommended by SAP. And not to be forgotten, moving to HANA, it's only supported on Linux today. So if you're coming from a different platform that may be SQL Server on Windows, you should consider also what you need to tool up Linux administration. Again, if you need a partner, we have partners that can help with that work as well. Now, in some cases where you choose to migrate systems over the wire, we'll get into this in just a moment, special care really should be taken into consideration, especially around data transfer speeds. I'll talk specifically about some suggestions there, but we recommend partnering really early with your network team and understanding your individual requirements and capabilities of what you have today and what you're going to need, especially during cutover. Now, the first one I want to talk about today is what SAP calls the Software Update Manager Database Migration Option, or DMO. They offer this option as a one-step migration from other databases to SAP HANA. And this is actually really cool in that it actually combines and automates multiple migration steps, including things like Unicode conversions, upgrade to new SAP enhancement packs, and the actual migration of from one database platform to HANA. Now, customers can utilize the DMO tool to migrate their databases to SAP HANA and AWS. Outside of the specific software levels required to use DMO, the primary considerations here obviously are your network bandwidth and the amount of data to be transferred, and the amount of time available for the data to be transferred, right? So you want to plan your maintenance window, your outage window, especially for the cutover. Now, depicted here, there are a couple connectivity options, and where latency or bandwidth is really a concern, we recommend the use of AWS Direct Connect. And we actually support provisioning speeds of Direct Connect in 1 gigabit per second or 10 gigabit links increments. Small increments are available through our APN Partner Network. But to give you just a rule of thumb, if you need to transfer about a terabyte file over 1 gigabit link, that's going to take about 2.5 hours. So again, planning early with your network team to provision the right network throughput, especially for this DMO migration, is super key. Now, we have other partners who actually have their own customized versions of DMO. They've built some tooling on top of that to support the AWS platform as well. But in general, the process is to provision your new environment using the quick start. You then configure the DMO tool on premise and perform the migration with the DMO tool. And then what you need to do also is rebuild the application tier on the AWS side and then perform the cutover. Now, if for some reason your SAP systems don't meet the requisite support packs or software levels in order to use the DMO tool set, you can use what SAP calls the HANA classical migration scenario. This is what typical SAP basis guys know and love, especially for use of system copies and refreshes. This, however, does require a certified migration consultant. But the nice thing, it does allow for offline data transfer. So if you've got a fairly large SAP database, you can do the full system export, which again results in a number of files that can be used then on the import side. And you can transfer these over the wire, or you can actually leverage some of the other AWS data transfer options, like our import-export Snowball, which is a 50 terabyte storage device, which can be actually connected into your data center with the data encrypted and then actually transported via FedEx to our data centers. Another option is the storage gateway, or oftentimes we actually see customers make use of our S3 object store as an intermediate place between the source and the target. But what if we have SAP HANA already, we have it on-premise, and we actually just want to migrate it to AWS? Now, again, when you're migrating SAP systems to AWS, SAP HANA systems, you potentially really need to take into consideration your existing SAP HANA system and sizing on a different platform, and then map them again to the available deployment options or instance types on our platform. And note with X1's memory capabilities, you have the option to actually even consolidate multiple on-premise HANA databases onto one instance or even multiple instances on AWS and save quite a bit of money. The simple migration process here, again, involves using the AWS CloudFormation template that we provide through the Quick Start, transferring the full SAP HANA backup, again, either over the wire using something like SFTP, or if you're going to use S3 as the intermediate storage area, you can actually use the S3 copy command. This actually automatically parallelizes the file upload for you, which can actually improve that transfer time as well. You then recover your SAP HANA database on the AWS side, reinstall your SAP application servers, and then depending on your application architecture, again, you might need to reconnect your applications to the newly migrated SAP HANA system. Let's talk about HANA system replication. So for those who may not be familiar, SAP HANA HSR, the system replication tool set, is a native HANA functionality that allows you to actually replicate from a source environment to a target environment. And when you use HSR, the secondary database actually becomes an exact copy of the primary database and can be used as a new primary database in the event of a takeover or migration, as we're talking about here today. The advantage of HSR is that it's native HANA technology that replicates the data directly from your source system to your target system. As before, we use the CloudFormation template, the Quick Start, to actually provision our new HANA system. We established the HANA HSR in a synchronous mode from the source system to the target. Some new functionality as of SP12 with HANA allows us to actually use a backup to see the target environment. Prior to replication, or prior to this, a replication synchronization would actually trigger a full copy from the source to the target. So again, with this latest support pack, you can actually transfer a backup and use that to see the replication environment. Then basically you get these things synchronized and you perform a takeover to your standby database. Assuming you've already installed your SAP application servers, you're then ready to reconnect your ancillary systems, your satellite systems, and be off and running with your newly migrated SAP HANA system. I want to talk really briefly here about high availability and disaster recovery options. Now, high availability, HA, and disaster recovery solutions are really important for business continuity. And we provide a lot of different services that can be set up in a redundant way to achieve high availability. And really, SAP HANA on AWS, when being able to leverage multiple data centers using or what we call availability zones and multiple regions, really provide an unprecedented flexibility when it comes to, again, providing a reliable architecture for your business. Now, you can design very simple and cost-effective failover solutions using X1. Starting with Amazon EC2 Auto Recovery, which I'll go to here in just a moment. This feature is designed to better manage failover upon instance impairment. You can also design multi-data center, or what we call, again, availability zones, and multi-DR or region solutions by leveraging a combination of our native AWS features and the SAP HANA system replication functionality, either in synchronous mode when used in the same region, or asynchronous when going multi-region with your DR approach. And we've written an extensive white paper that talks about the various high availability and disaster recovery options available for SAP HANA, especially with X1. And we could probably spend an entire webinar discussing the options available for implementing these various high availability solutions. But what I've attempted to do here is outline all of these various options and try to quantify the RPO, the RTO, and both cost for high availability solutions as well as disaster recovery where it's applicable. And now options again range from the simple backup restore solution combined with auto recovery to a multi-AZ or data center or multi-region protection strategy for systems that have the most stringent uptime requirements. Now, note here we've also worked with a number of our partners to help automate many of these failover tasks. Today we've got the SUSE SAP HANA Replication Failover solution, as well as NEC's Express Cluster to help automate this for you. Also note, starting with HANA SP9, you can actually leverage their Python-based API included with HANA to create your own HRDR provider and integrate it with the system replication technique to actually automate the failover process. I am, however, going to really quickly dive into a couple solutions to combine a couple features that we are finding quite useful for customers. The one I want to actually hone in on here is auto recovery, and then HANA system replication without data preload, because I think it really provides the best balance of resiliency and recovery time. Let's talk really quickly about Amazon EC2 auto recovery. Now, the auto recovery it's a feature of EC2. It's designed to increase your instance availability, and you can actually enable auto recovery by just creating a CloudWatch alarm in the console that monitors this EC2 instance, and then will automatically recover the instance if it becomes impaired due to an underlying hardware failure or a problem that involves AWS, that requires AWS to actually repair the instance. A recovered instance actually is identical to the original instance, including the instance ID, any IP addresses, elastic IP addresses you might have actually allocated to the instance, and all the instance metadata associated with it. So it's as simple as, you've got a system running here. We actually detect a depairment at the host or hypervisor failure, or even a loss of network connectivity, and let's say the instance becomes unavailable here. As long as you have this CloudWatch alarm set up, it will actually detect and trigger a workflow to migrate your virtual machine to a new physical piece of hardware. So actually take and deal with the failed hardware, and you're off and running again in a matter of minutes. In essence, you're actually able to leverage our spare capacity for your high availability needs at no additional cost. The other one that I think is super interesting and unique to our platform is this idea of auto recovery plus HANA system replication without data preload. Now, in this solution, you're hosting the primary SAP instance in one availability zone and setting up a secondary HANA instance in a different availability zone. And what you do is you set up HANA system replication between these two instances. Now, with HANA system replication in place, these data changes that are happening on the primary are persisted or transferred to the secondary instance. Now, with the HANA data preload option off, however, they're not loaded into RAM, but they are persisted to disk. And with this option turned off, again, you don't really need the same memory capacity as you have on your primary instance. So this helps you lower your cost while still protecting your system against really data center-wide failures. Now, we recommend you choose an instance size with at least 64 gigabytes of RAM, or whatever the row store size is, plus about 20 gigabytes, whichever is higher, as your secondary HANA instance and availability zone B. So what happens? So during a failover, you actually simply shut down the secondary smaller instance, and switch to a larger instance in the console that's identical to what you're running on the source side. In this case, we'd be resizing to an X1 32XL, a 2 terabyte instance, and once it's back up and running, we're loading things into RAM. We're not having to recover from backup, again, since the data was already staged in disk. We're just loading data into memory, and we're off and running. So it really provides you with a unique, cost-effective implementation of HA for SAP HANA that spans multiple data centers and minimizes your recovery time. Multi-data center approaches really don't have to be for disaster recovery only anymore. So this time I'd like to go just a bit deeper into the AWS Quick Start. As previously mentioned, our Quick Start reference deployment for SAP HANA really helps you rapidly deploy a fully functional SAP HANA system on our platform, following best practices from both AWS and SAP. And the Quick Start really ensures that the solution that you're getting, whether it's the instance, the volumes, the operating system configuration, are configured optimally to achieve the best performance of your SAP HANA system right out of the box. So we'll configure the virtual private cloud, the HANA cluster if you like. Again, auto recovery that I've just talked about, we'll configure that for you as well. We'll configure the security groups, the firewall rules that allow access to and from the instance, again, per AWS and SAP best practices. And again, it really doesn't matter whether you're deploying a single node or a multi-node HANA deployment on X1, or the Quick Start actually supports both of these types of deployments and is customizable for both of them. And it takes really less than an hour for either of those deployments. Now, even though I actually show access to the SAP HANA environment that's delivered through Quick Start is coming through the internet, you can choose to make these instances only available through your data center, right? So there doesn't have to be internet connectivity here. In many cases, what we're seeing enterprise customers do is just this. They're actually extending their network from their data centers over a VPN tunnel or a direct connect link like I mentioned prior to this. And in many cases, their end users don't even know that they're running on the AWS platform. So this time, I'd actually like to dive into just a quick demo. Given that the deployment takes about 30 minutes or so, I've taken some time out of the waiting process, and I've optimized it such that I'm going to show you the basic parts and pieces of the actual deployment here, and then you can actually see what it takes to actually step through this process. So the first thing we do here is we actually just navigate to AWS to Amazon.com/quickstart. Here you'll find a myriad of quick starts ranging from SharePoint. Again, the idea behind quick starts is to take very complex software deployments and make them super easy and simple to deploy on the AWS platform. Down past some of the to the SAP on the left to deploy. It launches as a console. Here, I'll tell you, item template itself or through the parameters that we actually expose for you in the CloudFormation template itself. Here, I'm just going to click Next. One of the first things we'll do is we're just going to actually name the stack. This will allow you to actually go back and determine which components are actually configured as part of this deployment. The other thing that you have an option to do is to change the CIDR ranges for both the entire VPC, if you're creating a new VPC, or to change again the subnet CIDR blocks for both the private subnet where we're deploying SAP HANA or the public subnet where we're deploying things like a Bastion host or RDP instance. Again, if you have an existing VPC where you want to deploy SAP HANA, this is something that can be done without having to go through this particular part. Here we're choosing which availability zone we want to deploy into. You're given the option whether to choose SUSE Linux or Red Hat, and here we're obviously going to be choosing the X1 instance type for our deployment. Note here also, this is where you choose the number of HANA hosts, so if you need a multi-node scale-out deployment, this is where you would choose that. We're going to turn on auto recovery, which is the failover mechanism which I talked about just a minute ago, specify a key pair for secure access to our instance. I'm going to choose here the general purpose volume type to optimize my cost, and I'm going to turn on encryption for these volumes as well. Here we actually see a set of parameters that allow us to customize the SAP HANA deployment itself. Note that I can actually change things like the domain name, the master host name. If I'm doing a scale-out deployment here, I'll actually change the host name of the scale-out nodes. And if we're doing multiple scale-out nodes, we'll actually increment for you a 01, 02, 03, and so on. This is key. It does not have the rights to distribute the HANA software, so we ask you to actually download the software, the HANA software, as you get from Service Marketplace, and deploy it into an SAP or an S3 bucket for us, and then provide the URL to us if you want us to orchestrate the HANA software install for you. Here I'm actually going to select yes for deploying the HANA software. I'm also going to use yes to RDP instance because I want to RDP into and deploy the HANA Studio. And then I go ahead and click next here. I always encourage my customers to actually tag everything they create. This is important because everything we build as part of this stack will actually be tagged with this key and value. So when I go back into the EC2 console and I want to search for all the parts and pieces that we deployed, you can actually search by these tags. I click next, and I'm actually able to go and, again, review all of the parameters that I just defined before I actually click create to actually create the stack here. So we'll click create here, and we're off and running. Now, literally, you could go get a cup of coffee at this point and come back in about 30, 35 minutes or so. I went ahead and actually pulled some of the waiting process out of the video here. So I'm just going to go ahead and hit refresh here. What you can see here is that we're creating, again, the various pieces of infrastructure. You can actually follow this from end to end. You see listed here, I just want to make note of this, 3 stacks that we've created. Your X1 demo is the base stack, and we're actually using nested CloudFormation templates. The base network, it actually creates and defines the entire VPC and the subnets. And the base nodes stack also is called from the main CloudFormation template to create the instances, including the SAP HANA instance, the Bastion host, the RDP instance, and so on and so forth. And again, so what we're looking at here is the entire process. And we look and we see we started this at 23:25, so about 11:25, about 36 minutes. Within about 36, we have an X1 SAP HANA deployed. Take a look. So we've already staged onto our Bastion host, SH into our tunnel into our HANA host here to do a quick SU to the SID ADM for the HANA instance and do just a quick check to see which processes are running. Here you see the SAP HANA processes are up and running. Take a quick look at the capacity. Again, you see 128 vCPUs spread with nearly 2 as shown by the free command here. Next, we'll actually navigate to the AWS console. Just again, take a quick look and see what's been deployed here. So we navigate here. We'll see that we actually have created 3 different instance types here. The 3 instances are obviously the X132XL, the Bastion host, which was we indicated here as a T2 small instance, and then our RDP instance or C4 instance here. We're actually going to just quickly log on here to the Bastion host, actually the RDP instance, and install SAP HANA Studio, and actually take a look at that view as well. So we'll grab here the RDP, or excuse me, the elastic IP address, RDP onto the instance, and configure just a HANA configuration within HANA Studio, system configuration. We pop in the private IP address of the SAP HANA instance, give it a good description. We'll enter the username system plus the password that we entered into the CloudFormation template when we first started, and click finish. And quickly here we see that we've got a HANA system up and running from the GUI perspective here. If we click on the landscape tab, we can see all, again, the various services and pieces that are running on the instance, similar to what we saw at the operating system level. And in a short 6 minutes, that concludes the actual demo. And so we'll continue on then to the rest of the presentation. So just a few slides. Hopefully you've seen that we've actually put a lot of work into taking a lot of the hard work out of actual deployment of SAP HANA Solutions, especially on X1. Really getting the deployment time and the time to value for your business down from weeks or months down to minutes, so that again, oftentimes when it comes to your projects, the amount of time that you're actually planning up front is much more than actually it takes to actually procure the hardware. So this thing just becomes something you don't have to worry about anymore. I've walked through various options for HA and DR as it relates to SAP HANA and migration scenarios, and hopefully you can see that there are a lot of flexible options when it comes to running these critical solutions on AWS platform, and really you get to focus on what is your core competency as you integrate your SAP workloads into a broader cloud strategy. I want to really quickly to show you just a quick 1-week pricing example, what it would take to run, say, a simple proof of concept for 40 hours for a week. I took the on-demand cost of the X1 instance here, along with the general purpose volumes, and it came out to less than $700. Note that you can actually save very significant amount of money over the on-demand pricing for X1 by either leveraging the 1-year RI purchase or a 3-year RI. In fact, up to 72% with the 3-year investment on the X1 instance. Getting started is super easy. We have account teams that are more than happy to help out and have discussions with you. Again, I absolutely encourage you to get started with the quick start deployment process. We also have an option here for you to apply up to $1,000, so enough definitely to try this POC for a week. We're going to be at the TechEd event in Las Vegas, mid-September. And then I'd encourage you also to register for the event you see listed here. We're going to be making some exciting new announcements with SAP coming on September 7th here. Just some additional links for further information on the X1 instance type. We have a complete microsite devoted to SAP. There's a lot of white papers and articles and customer examples out there as you look to deploy your own solutions on our platform. And with that, I'd like to thank you for attending the webinar today. I'll turn it back to you, Ryan.
Do you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS will cover in future webinars? Please feel free to send us an email at aws-webcasts@amazon.com. Again, that's aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thanks to the audience for taking the time to join us today, and enjoy the rest of your day.